Hi, welcome to Sachin Study Tech. Today topic is optimal merge pattern algorithm by using greedy. Merge a set of sorted files of different length into a single sorted file. We need to find an optimal solution where the resultant file will be generated in minimum time. If the number of sorted files are given, there are many ways to merge them into a single sorted file. This merge can be performed pairwise. That's why it is called as a two-way merge pattern, two-way merging. So you can merge in different ways. M-way merging is also there. At a time, for example, you can merge three files. That is the three-way merging. At a time, you can merge four files at a time. That is called as a four-way merging. At a time, you can merge M. So that is called as a M-way merging. So here the time complexity is big of n log n. The space complexity is big of n for the optimal merge pattern. So for example, so these are the list. So this list 1, here it is a list 2. So this list 1 is consisting of some elements. This list 1 is consisting of sorted elements. For example, here the element is 2 and 5. For example, this next element is 8. So here the list 2 consisting of some elements, that is for example 1 and for example 8. For example, here it is 12. So these are the elements is there. So these list consisting of 3 elements, these list 2 consisting of for example 4 elements. Then the size of this list 1 is, the list 1 size is, here it is 3 elements is there. So that is equal to, for example, m equal to 3. Here the size of the list 2 is n, that is equal to, here it is a 4. So what is the time complexity of merging these two? So the time complexity is big of m plus n, m plus n. So m is the number of elements in the list 1, that is 3, plus n is the number of size of the list 2, that is 4 elements is there in list 2. So the time complexity of these two lists can merge into single file. It is a big of 7. So how can merge? Can take the another list. So okay, for example, here it is indicates the I, here it indicates the j. So you can compare I less than j, which is the minimum. You can store it here in the resultant list. So here it is incremented by 1. So you can compare with 2 and 8. 2 is the minimum. So you can take the 2 and incremented by 1 here. And also you can compare with 5 and 8. So 5 is the minimum. You can store it. So then you can increment by 1 and 8. For example, here it is element is 9 and 8, you can compare it. So 8 is the minimum, so you can store and you can increment. So 9 and 12, so 9 is the minimum. So there is no elements in this list. Then what are the elements is there in the second list? You can all copy here the 12 and 15. So this is the sorted list. How much of time you can take this? If you can merge these two lists, list 1 and list 2 is, that is big of m plus n. But here, for example, let us consider the given files f1, f2, f3 and f4 and f5. So these are the file size. F1 size is 20, f2 size is 30, f3 size is 10, f4 size is 5, f5 size is 30. It is not, so 20 is not an element here, the size of that file. So that means the file f1 consisting of 20 elements, f2 consisting of 30 elements, f3 consisting of 10 elements, f4 consisting of 5 elements and f5 consisting of 30 elements. So these are the sizes of the files. So how can merge? For example, here the different way to merge. For example, here elements is there 20. For example, you can merge these two, 20, 30, that is 50. I am using the two-way merging, and 50 and 10 you can merge it. Here it is 50 plus 10 is 60, and 60 and 5, that is 65, and 65 and 30, that is 95. What is the total cost of this merging? Here this is a one pattern. We have that the more number of patterns is there. Out of those patterns we can find out the optimal one. So here it is 50 plus the cost of total this pattern is 50 plus 60 plus and 65 plus 95. So that is equal to 5 5 10. So 0 1 and 10 16 16 6 22 22 5 27. So 227 number of comparison is required for this pattern. So another way can merge it. Here it is, for example 20 30 10 and 5 and 30. Here it is, for example you can merge these two elements first. 5 plus 30 that is 35 and 10 and 35 that is 45. So 45, here it is 45 and 30 that is 75 and 75, and here it is 20 plus 75 that is 95. You can see here it is 95 plus 75 plus 45 plus 35. So here it is 5 5 10 15 20 0 2 5 plus 4 9 9 plus 7 16 16 plus 9 25. So here it can require the total number of comparison is 250. So here you can take the number of patterns are possible. So out of those number of patterns we can find out the optimal mesh pattern. That optimal mesh pattern requires the minimum number of comparison. You have to find out that. So by using this greedy method you can solve this problem. So how can solve this problem? Here you can see first what are the files is there. All the files in you can note down in the sorted order here. For example here it is, here the file is minimum is 5 that is equal to F4 file F4, and next one is 10 that is F3 10, and next shortest size of the file is 20 that is F1 20, and next size is here the 30 and 30 either you can write any order. So that is F2 30 and F4 that is F5 30 F5 30. So first two-way it can follow the two-way merging. You can use a greedy method here. So we can merge these two. 5 plus 10 that is 15, and 15 plus next minimum we can see here the 15, here the 20, here 30 30. So 20 and 15 is the minimum. So we can merge these two, that is equal to 35 and 35, here the 30 30. So these are the minimum. So you can merge these two. Here 30 30 that is 60, and 60 and 35 it is 95. So how many number of comparisons is required for this pattern is 95 plus 60 plus 35 plus 15. So 5 5 10 15 and 5 1 2 5 11 20. So here it is 205 number of comparisons. So this is the minimum number of comparisons. So that's why this pattern is the optimal mesh pattern. So another way also can find out here. For example here it is, here that 205 number of minimum number of comparisons is required here. So for example I am consider this is the 5 and 10. For example next weight is 20, and for example 30, here it is 30. So you can compare these two. First minimum, these are the two minimum pair. Here you can compare these two. 5 plus 10 that is 15, these are the file sizes. Here are the file sizes. Then these are the two are minimum, so you can merge it. Then 15, 20, 30, 30. So 15 and 20 is small, so can merge these two. Here it is 35. Here the 30 and 30 is the minimum, so can merge these two. Here 35, here 30 and 30. So these two files are small when compared to this file size, so it is 60. Then here 35, 60, that is 95. You can see another way also, for example, how many number of, so here you can see the size is 15, 35 plus 60 plus 95. So that is equal to 205. For example, here how many labels is there? Here this is one level, this is the second level, here the third level. 3 levels is required here. So 5 into 3, that is 15. You can see here it is 15. You can see 10. Here also one level, second level and third level. 10 into 3, that is 30 plus here 2 levels is there. This is one level, this is one level. So 20 into 2, that is 40 plus here you can see 2 levels is there. 30 into 2, that is 60. Either this way also can calculate it. So here it is 2 level, this is 1 and this is 1. So 30 into 2, that is also 60. You can see here the 60 and 60, 120, 120 plus 40, 160. So 160 plus 30, 190, and here the 15, that is equal to 205. So the total number of comparisons is required. 205 number of comparisons is required. This is the optimal merge pattern. You can merge any way. So for example, first 5 and 20 and 10 and 30, like you can merge it, but here these are the minimum number of comparisons. So this is the optimal merge pattern by using greedy method. So this is the time complexity, this is the space complexity of the optimal merge pattern. Thank you for watching this video.